Hello, everyone, again. Uh, so the next presentation, which is modeling of large-scale social data, will be given by Marija Mitrovic Dankulov. So I will briefly introduce her. Marija is research professor at Scientific Computing Laboratory and head of Innovation Center at the Institute of Physics Belgrade, the National Institute of Republic of Serbia. She completed her PhD in statistical physics at the Faculty of Physics, University of Belgrade. She has extensive knowledge and experience in theoretical and computational physics. Her primary research interest is application of statistical and complex networks theory for studying socio-economic systems. Maria, hi. I'm leaving the second to you now.
Okay, thank you. Thanks very much. So I'm going to give a hands-on about a network analysis, one of the relatively new modules for using for network analysis, where you can actually use GPU resources to do this. But before that, I would like to shortly present you, like half an hour, about why we want to do this and why it's this important for us. So, just a second. So I'm coming from Scientific Computing Laboratory, and this is a center for study of complex systems. And we study different kinds of complex systems in this laboratory, mostly physical motivated systems. So Bose-Einstein condensation, strongly correlated systems, and similar kind of systems from solid state physics. But we also have a group of physicists who study social systems or socioeconomic systems. And we are mostly, unlike our colleagues who are doing traditional physics, we are mostly oriented toward very high performance data analytics and using our cluster and AI tools to actually extract the information from the social data and to map it on different kind of objects and models and to analyze different kind of behaviors in these systems. So this is a very kind of old statement, so to say. So we kind of had different kind of stages of web development in information communication technologies. So basically we started with Web 1.0, where everybody, where we had websites and other things, but we were not able to create content on the web or use it to really communicate with strangers. But with development of 2.0 web, it kind of became a medium for human communication. And this kind of opened the whole deal of scientific possibilities or possibilities for scientific research and for studying of social systems. And physicists and computer scientists actually entered this field in approximately that moment, and together with scientists from sociology, from psychology, and from economics, they kind of created a field, interdisciplinary field called computational social science. Today, many of our aspects of our life actually are happening online. Even this talk or this workshop actually is happening online, and we create a large amounts of data, whether it's social media websites, news websites, different kind of data sets that we can actually collect. All of these are places where we communicate, exchange knowledge, exchange ideas, but also these places also influence our offline behavior. And that's why we actually try to understand how certain aspects of human behavior come together online. Social systems are complex systems, but in general, complex systems are defined as a systems that consist of very large number of interacting units, and they exhibit so-called emergent collective behavior. I will talk about collective behavior in a few minutes, But social systems are type of complex systems. They consist of a very large number of interacting individuals, whether this is online or offline. Social systems have this property that they're self-organized, so there isn't usually a central force that shapes the behavior of these systems, but their behavior is shaped through interactions between their elements. And they can display different kind of collective behavior, order, disordered organization that we usually see in physical systems. This is, for instance, from opinion dynamics. If you start with the people who each one of them has very different opinion about some topic, if they communicate long enough, you will see a kind of alignment between them with one or two or three opinions about a certain topic. Unfortunately, what we saw in the past 5 years or 4 years is the spreading of very, very dangerous disease, COVID-19. But spreading of disease is also one type of collective behavior, but we also spread innovations and information through our networks. And we also see kind of popularity emergence and different kind of collective behaviors. So what is our goal? Our goal is to determine and understand the principles that govern this collective or that lead to this emergence of collective behavior in the complex systems, and specifically in our case, social systems. And our means are, first, we need to quantify this collective behavior in empirical data, and then to develop different kind of theoretical models, starting from like toy models to models that are more complex, like data-driven models, to actually study different kind of scenarios for emergence of specific collective behavior. And in the end, our group is also doing, in a very, very rudimentary sense, social experiments. So what is the collective behavior in social systems? So you saw the birds that are flying and make this very nice pattern. Believe it or not, this is one example of social system, and these patterns that we see and the flocks of birds, this is what the collective behavior means. These patterns and the flocks that fly together synchronously would not exist without the interaction between birds and without the fact that birds try to kind of align their direction of flying and the velocity of flying with each other. There's a lot of research done from physics perspective and also from data science perspective about this in the past 20, 25 years. And a lot of different kind of models were used to explain different kind of behavior in birds, a flock of birds. But we are still kind of missing some details, and there is still research ongoing about this. Schools of fishes are also type of collective behavior. And for instance, in social systems, if you were on any kind of stadium and you saw this Mexican wave is a very nice example of collective behavior where people kind of stand together and synchronize their standing and sitting. And due to this, we see this beautiful wave that is going around the stadium. Riots are definitely collective behavior. And as I said, epidemics, spreading of information, spreading of diseases, spreading of innovation is type of collective behavior in these social systems. In the basis of every social system or any kind of, so to say, these non-traditionally physical complex systems is a social network. This network, unlike typical networks that we see, networks of interaction that we see in solid state physics, which are usually lattice-like, they're very translationally symmetric. In the case of social systems, in the case of biological systems or technological systems, they're very unsymmetric, have very specific structure. And actually for the past 25 years, physicists, computer scientists involve a lot of time in studying the structure of these networks, how they emerge, how they influence the dynamics of these kind of systems, and why we see them. here you can see several examples of complex networks. One is a social network. So if you ever looked, and we will see, if you ever looked at for instance, network of Facebook or of Twitter, you will see that it's not regular, it's complex. You will see that there are people that have a lot of followers. There are much more people that have relatively few followers compared to them. So it's very, very heterogeneous network. But this network is not the only one. We can also see networks in the, for instance, network of words. We can see complex network. Our brain is one of them. And for instance, this one on right lower corner is the example of network of airports in the USA, where each airport represents a node, and the connection between them is actually the number of flights that are flying daily between each of these airports. So in this talk, I will show you some of our results on two types of collective behavior. One is collective emotions in cyberspace. This is quite old result, but I still like to talk about this because it's one of the first things that I studied as a scientist 15 years ago. And the other one is quite recent results that my group is working on, and we have an active project about this, and that's a collective trust in online social communities. And actually, social networks are in the basis of our studies. Quantifying and measuring collective behavior is quite complicated problem. And we use threefold approach, as I said. So we use empirical analysis, agent-based modeling, and some experiments to actually confirm the hypothesis that we make through empirical analysis and agent-based modeling. And here I will talk about the empirical analysis because it's a kind of data science focused approach. And I will tell you a little bit how we use complex network theory to actually determine the structure and its relation to dynamics in social systems, a little bit of time series analysis, which can reveal us interesting information. And I will also show you how we use dynamic reputation model of users to actually study certain dynamics of collective behavior in social systems. So the most important thing, as I said, is a network. Unlike social networks, typical that we see, in which we have users or people as nodes in the network, and links between them or edges between them represent certain kind of interaction, whether it's a friendship or a relative interaction, or I don't know, for instance, in telephone communication networks, it means that people communicate with each other. In online social communities, we also have to recognize that people communicate through so-called artifacts. So these are usually either blog posts or certain topics on Twitter, or certain Facebook groups, or for instance, in the case of Reddit, it can be also a subreddit, and so on. So we actually need to have two types of nodes. One is user nodes, which is a typical an active agent, and the other is usually post, comment, or question and answers, like in the case of Q&A, Stack Exchange or Stack Overflow network. So what we basically have is two partitions, users and posts or questions. And these networks can be of different types. Usually we prefer to use undirected networks, but they can be directed, they can be binary. This means that each link has the same importance and the same weight, or they can be weighted. In some cases, for instance, when we project this bipartite network to partition of users, then we talk about, usually we calculate the weight between two users if they are active together on a certain number of posts, and then this number actually represents the weight of the link between them. And what does this mean? The more two people are interacting through different posts or through different, for instance, subreddits, there is a higher probability that they have certain kind of common interest, or they're interested in the common in similar subjects. And so in this network, we can actually study this kind of behavior. What we do is that we study either topological properties of bipartite networks, or we can actually study their projections on user or post or question partitions. Why the social data is, or online data is so interesting? It actually gives us a lot of information about behavior users, typically either on different kind of platforms people register. So you can actually follow their dynamics and their behavior in time. Their actions are timestamped, so we can actually very in detailed way, we can follow their activities. So we have very high time resolution. What is more interesting is that people actually communicate through messages. The text of these messages or comments or posts are available to us, so we can actually extract different kind of information from these text. In this case, we extract the information about the emotional content of messages, but you can also use different kind of computer science approaches to extract if there is a hate speech in these communities. You can extract information about topics of specific messages, or any kind of other information that you can actually extract from these data. And these data represent a very rich data set for all people who want to study actually social data, social behavior. The reason for this is that if you want to collect this data offline or in the control setting, usually you cannot do that on that large scale, or you cannot actually collect such a detailed data on these, like in online communities. That's why we actually look at these data sets. And here, just one example, what you can extract from the network. So this is a network of BBC posts. This is a quite old data set. It was collected in 2009 when the blogs were very popular, and BBC had a kind of popular blog posts. And we collected the data for posts from different kind of topics. So there were, I think, if I remember well, 5 types of topics. So there was sports, business, and economy and technology. Besides this, there was music, and I think it was science in one moment. And we actually had a very large data set where we actually found out that there are posts that are kind of, we call them normal. So they're not that popular. Usually they have below 100 comments, and they're popular posts, not as much as normal ones, but actually they're still present in the data sets, which have more than 100 posts. And we actually divided this data set into 2 types, so into 2 sets. So normal and popular posts, we mapped it on bipartite network. We projected this network to users partitions, and then we used Laplacian approach to study the community structure. Many of social networks have these groups of nodes that are more connected with each other than with the rest of networks, and this is defined as a community in social systems. Usually these communities tells us something about the structure or about the evolution of system. What we found out is that in the case of normal posts, so each branch here represents one community. In these branches, each of these branches represents one community, and these communities are grouped around the posts that are on specific topic. So this means one is sports, one is about posts on business and economy, and one is about posts on technology. On the other hand, if you look at the popular posts, and user communities form on this, you will again see branches, but what you will find is that they're mixed. So the topic is not that clear anymore. So you will find users that were both active on sports and business and economy that make one group. And what we found out is actually that emotions are the reason for this. Usually popular posts are more emotional than the normal ones, and the emotions are the things that actually drive the discussions in them. Even more, we looked at the Dig dataset. Dig is a website that was very similar to Reddit in 2000s, early 2000s. So yeah, early 2000s. So between 2005 to 2009, this data set was collected actually in 2009. It was collected for 3 months, and the data set had more than 500,000 users that were active, more than 1 million stories, and I think comments were more than 2 million or something like that. And what we looked at the time series of emotional comments. So this means that for each comment, we determined whether it's positive, negative, or neutral. And then we made a time series with the resolution of 1 day, where each point represents the number of comments of specific emotional content in that specific day. And we didn't look at the whole data set, but we actually looked at the data, at the posts that were popular. So this means they had over a certain number of comments. So this means more than 100 comments. And we were actually interested because on the Dig, like in the Reddit, you can post a comment on specific post, or you can actually post a comment on already existing comment. And we looked at the data, the posts that were discussion driven. So this means that more than 50% of comments were actually posted on another comment, not on a specific story, which showed us that people kind of engage in discussion in this kind of posts. And we looked at time series of emotional comments, number of emotional comments on these posts, analyzed this time series, and we actually looked at so-called avalanches of emotions. So this means that we kind of determined the threshold here, and we looked, so the threshold, whenever this line crosses the threshold, the total number of comments between 2 points of crossing the threshold is called an avalanche. We looked at the sizes of these avalanches. So this means that the total number of comments for this specific time period. And if you look at the distribution of sizes of these kind of comments, this is here, you will see that it actually follows power law distribution. What does this mean? This means that we have a lot of avalanches that are of relatively small size, and then we have still some non-trivial probability that we will have avalanches that are really, really huge, like almost several tens of thousands of emotional comments that exist. This we saw actually for negative comments on Digs. We didn't see this for neutral comments. We didn't see for positive comments. So this means that negative comments are mostly driving the discussions on Dig website at that time. And actually, if you look at the percentage of negative emotions or negative comments in this data set, it's more than 50%. So it's very negative community in the sense they're very negative emotions. And besides this, you can also look at the Fourier transform of this time series. And based on this, you can actually, by analyzing it, you will see a power law power spectrum, which shows you that the whole system is something that we see in physics as a self-organized criticality system. So this means that this system has tendency to relax each time whenever there is a critical threshold, certain things happen. It kind of relaxes through this emergence of these emotions and these kind of stuff. So you can see this, for instance, in sandpile models. I will skip this because I want to talk collective behavior, collective trust. So what we studied here is stock exchange network. stock exchange communities, and there you have communities that were started about a certain topic, they lived for 6 months, and then they were closed down because there was no enough interest. But later, the same topic was tried again, so they again started with a specific topic, they build a community, and that those communities exist again still today. And we wanted to actually understand what are the differences between these two types of communities. So we mapped the data onto networks, we studied their structure, and we also analyze user dynamical reputation of users based on their how often they're active in these communities and how sparse these activities are in this system. What we found out is that these communities are quite cohesive. So this means they have very high clustering coefficient. So this means that there is very high probability of triadic closures in these communities. So these full lines are active communities, they still exist today. And the closed communities are these dashed lines. And as you can see, in all of them, this clustering coefficient was very much higher than in the case of closed communities. Besides this, we looked at core periphery structure and how this core periphery is connected, how core is connected with periphery and this relative number of connections between them. And what we found out is that, again, these active communities have more stable and better connected cores than these closed communities. And in the end, we looked at the mean dynamical reputation of people who are in the core of these communities, and we found out that actually active communities, the ones that are still alive today, have much more trustworthy individuals than this is the case in the case of closed communities. I hope I motivated you to see how you can actually explore the data online. There are many tools that you can use, but this is quite interesting data source, so to say, especially for people who want to study social networks and social dynamics. And what we see from these findings is that collective emotions are happening in avalanches. This means that we can actually predict that avalanche will happen, but cannot predict how large that avalanche will be. And we see that successful communities are quite cohesive and have very stable, trustworthy individuals. I want to thank to my collaborators, and of course to thank to first EuroCC for SE, who supported this workshop, and of course to our national funding agency who supports our research. Thank you very much.
Thank you, Marija, for this informative talk. I think there are some questions. First question is, do you also consider collecting and analyzing other types of data, such as age, sex, and education?
No. This is usually not available, but also we really try to not collect the data about kind of personal data about people. So we try not to collect the names of these people. So we usually don't collect the data, for instance, from Facebook, not just because of this, but it's one of the ways. But sex and other things that can kind of tell us more about the people, we really try to avoid, and we always do data anonymization and other approaches that actually kind of keep privacy in some sense.
Another question. Which methods do you label the data as negative or emotional?
So at the time when we used this big data set, our colleagues from Wolverhampton had their own model that was using a dictionary of affective English words. And they developed a model that allowed them to describe a certain message as a positive, negative, and neutral. So it was dictionary-based algorithm. But today you have different kind of approaches. My group uses Vader. This is a very nice, again, rule-based approach that is used for determining the emotional content of a certain text. But you can also find other approaches that were, for instance, based on BERT, on other networks. You can also look at Hugging Face. There's a lot of freely available data sources for this.
Yeah.
Just to say, be careful, because all of them are trained on the specific type of data. So always check whether this data set is the best. This approach for finding the emotional content is the best for you. So that's my advice.
Thank you. Another question. How do you get these negative comments? Did you apply some filter that identifying bad words?
No, as I said, that's already explained in the previous question. So basically we used a software, AI-based, machine learning-based approach.
Okay. So I think we can have some coffee break now.
Yeah, but there is a question, how did you get the permission for collecting the data? So Stock Exchange is freely available. They dump their database every quarter. And for DIG, our colleagues collected this data long time ago.
I missed the other. And I think the participants missed the part that tools we can use.
I'll explain one tool in the hands-on, okay? But these are not the only tools that you can use for this. Mostly it's based on Python.
Thank you. Then we can have 10 minutes coffee break now. Then we will continue with the hands-on session. Thank you.
Thank you.